Now in this video, we are going to talk about how to build web APIs with Docker containers on AWS. Now with Amplify CLI, you can provision, configure and deploy serverless containers. We just have to configure the project to use container-based deployment and then do Amplify push. Now, although this is just couple of line of command, Amplify is going to configure a bunch of services at AWS end to build a production-ready architectures behind the scene. Now, here are some services that it will configure for us. It's going to create a VPC to handle our networking, API gateway as our RESTful API. Of course, GraphQL APIs are also possible. And then we have CloudMap for service discovery, then ECR or Elastic Container Registry to store our Docker images, and then Fargate. Now, this is particularly used to run our containers at scale with serverless compute. And then, of course, it's going to use a code pipeline to build and deploy images into this Fargate cluster. So Amplify is going to handle everything for us. So we just have to focus on our business logic, and the Amplify CLI will provision all the resources that we just seen and all the configuration and deploy to the AWS as well. But I think you'd agree with me, as developers and cloud architect, we should really understand what's happening behind the curtains. Because in future, then we can make some informed decisions for our architecture. And let's do that in just a bit, but I think it's best that we will refresh our knowledge about containers and serverless functions so everybody is on the same page. Now, prior to containers and serverless functions, we used to host our web applications directly inside physical servers. And there we spin up a web server inside it and serve the code. Now here the main problem is scaling, guys. You cannot scale horizontally for storage or for compute. Now, if you want to scale, that has to be only vertical. That means you need to buy new hardware like RAM and hard disk, and that's going to cost you quite a bit. Next, virtual machines were introduced thanks to virtualization technologies. And with virtualization technologies, you can run multiple VMs or virtual machines inside a single physical server. And this can be done in a highly isolated manner. Now, this is what allowed cloud providers like AWS to provide VMs for their customers at low cost. Now, EC2 service is a good example here. Next came the containers, and they use containerization technologies. Now, here the Docker engine is a very good example for containerization technology. Unlike in a virtual machine where you need to install a fully blown guest operating system before you run your applications on the VM, Docker allows you to just install a thin layer of Docker engine software on top of the physical machine and then run many containers on top of it. So people started to embrace containers quite a bit. And then came the serverless functions. And here you don't have to worry about provisioning resources at all. You know, the cloud providers like AWS provided services like AWS Lambda, which is fully managed, and you only have to put your business logic inside Lambda functions that is managed by AWS Lambda. And AWS Lambda is going to handle the scaling for you. Now, this became a game changer for web development since we only have to pay for the execution time of the Lambda function. So now let's compare and contrast between containers and serverless functions. Now we already talked about these serverless functions continuously scales, and apart from that, we can invoke these functions on demand. Now most of these functions are event driven. That means these can be triggered by various events like HTTP events, or you can trigger a Lambda functions when you upload something to AWS S3. And then this AWS Lambda is a fully managed service. That means it will automatically handle the scaling for us, logging, monitoring, tracing, and also the integration with other services as well. But however, guys, there are some downsides to AWS Lambda as well. For example, these AWS Lambda functions are affected by cold starts. That means there's an initial delay to start up the Lambda function if it is not invoked for some time. And also you cannot run long running servers in Lambda function, and that is not suitable for that. For example, it might not make sense to train machine learning models inside Lambda functions. So the rule of thumb is if you have some constant workloads, Lambda might not be appropriate because it is particularly good for event-driven code execution. So this is a problem. And what if your application requires one of these constants workload to be run? So in that case, you are free to incorporate containers into your serverless architectures. So it's basically we can use functions and containers in tandem. And nobody says you can't use both serverless functions and containers in the same architecture. So it's all about understanding your use case properly and use these technologies wisely for better performance, cost optimizations, and so on. Okay, so let's imagine you decided to have containers in your architectures. So where are you going to run them on AWS? Now, there are multiple options, guys. First and foremost, you can use EC2 instance. Now here, you will get the complete control over your container workload. You can use EC2 instance or fleet of EC2 instance with auto scaling. And here you can make, for example, a Kubernetes cluster and install it, configure it by yourself. You can install Docker, Docker Compose, and you have the full control. So that's the first option. Next, we also have Elastic Beanstalk. Well, Elastic Beanstalk is a PaaS offering or a platform as service offering. And in Elastic Beanstalk, we can use Docker platform to run your containers inside EC2 machines behind the scenes. Now, you don't have to worry about provisioning and managing these EC2 instances. That will be done by the Elastic Beanstalk. And if you got multiple Docker containers to run, then Beanstalk will use ECS service or Elastic Container Service to create a cluster and then run the containers inside it. And there are more options like you can use AWS Lightsail. Now, Lightsail is ideal if you are new to AWS and you got a Docker image to create containers out of it. So what you have to do is you just have to log into Lightsail console. Of course, Lightsail has its own console, and then specify how many compute nodes do you need and the power of each node, like the CPU and the RAM, and then provide the Docker image. That's it. The Lightsail will take care of it and create containers that you specify. And we also have Elastic Container Service and Elastic Kubernetes Service. We call them ECS and EKS for short. It's right here. Now, ECS or Elastic Container Service is a fully managed service to orchestrate containers on AWS. And ECS is a proprietary container orchestration service from AWS. But if you're already using a open source container orchestration system like Kubernetes, then you can use EKS. Now, EKS stands for Elastic Kubernetes Service, and that will allow you to run Kubernetes application at scale. Now, both ECS and EKS allows us to use AWS Fargate as the serverless compute engine. Yes, you heard me right. That is serverless. So that means you don't have to manage EC2 instance for your ECS cluster or your EKS cluster. And that is going to take away quite a bit of admin overhead to manage your EC2 instance to power up your ECS cluster or EKS cluster. Okay, so for the rest of the presentation, let's focus on ECS and Fargate. Alright, so now let's get to the meat of this episode, and that is about building web APIs with Docker containers. Now, there are certain considerations when we are building APIs with Docker containers, such as the API should be able to call with HTTP requests. We can, of course, have a REST API or a GraphQL API in front of our containers, but that API should be accessible over HTTP requests because most probably our API will be consumed by a front-end application. And also, it should support auto scaling for containers when there are many requests coming to the API. And another concern could be if we only want our authorized people to access the containers, then that user authorization should also happen or handled at the API level. Because as you may know, it's not a good practice to add authorization logics everywhere in the architecture, but we should try to decouple that, maybe put it at the API level. So the business logic that is inside containers and that runs behind the API do not have to worry about authorization rules. And there could be many more concerns, but I chose these three. Next, let's discuss two approaches to expose container-based web APIs to the outside world. And here's the first approach where we'll be using ECS, Fargate, and ALB, which is short for Application Load Balancer. Now, first and foremost, we need to set up our virtual network. Now, here I'm showing one public subnet and two private subnets. Now, whatever the resource that we put into the public subnet will have access to the internet because there's an internet gateway attached to that, but private subnet do not have access to the internet. So those resources will not be able to communicate with internet. Now, each of these subnets correspond to a different availability zone. In other words, data centers in different locations. And next, we are going to create a ECS cluster that span across these two private subnets. So this could be two or more subnets, but here I have used just two. And after that, we can spin up a ECS service which is going to manage some containers for us. You can of course have multiple ECS services, and each ECS service you can define what is the Docker image that you want to spin up these containers, and what is the desired number of containers that you want to run all the time. And also you can enable auto scaling, so when there are so many requests it can create more containers to serve them as well. Okay, so we have our cluster and our service, and then we have our containers running in this case two subnets, that means two different data centers. So now how can we access these containers? Now here in the first approach, we are going to use an application load balancer that runs in a public subnet. Now since this is running inside a public subnet, it can be accessed over the internet by any users. Now this application load balancer operates at layer 7. So what does that mean? So that means it can access the headers of these HTTP requests made by these users or any other application in that matter. And then you can make different rules based on those header information. For example, you can look at the host names, the request paths, and then point them to the related ECS service. And that is really cool. Now here's a question for you. How does the load balancer knows the IP addresses of these containers so that it can route traffic to them? Well, if you think about it, the load balancer itself does the service discovery. It's going to keep track of the IP addresses of these healthy containers that belongs to these ECS services so that it can route traffic to them. Now, this process of identifying the resource IP addresses and ports is called service discovery, and ALB performs, or the application load balancer perform it by itself. But however, in this first approach, we are going to lack some API features in the application load balancer. For example, user authorization. Although the ALB has features to authenticate requests with the Cognito user pool and so on, you can't really have complex authorization logics. And what about the throttling of request? And that is a requirement for an API, but application load balancer does not support that too. And we might need different stages like production, staging, dev, QA, like that. But ALB is not going to support that too. So this is why we are going to look at the second approach. And also I want to tell you that when we are deploying containers from Amplify CLI, it is going to follow this second approach. So in this approach, we are going to use ECS, Fargate, CloudMap, Cognito, and API Gateway. Now, first and foremost, as usual, we need our VPC. Now, this is our network that we are going to run our containers. But in this case, I have omitted the public subnet because we no longer use that application load balancer, so we don't need a public subnet. And as usual, we are going to have our ECS cluster that spans across these two subnets, and then we'll have our ECS service that manages some containers. Now, earlier in the first approach, we used an application load balancer to access these containers from outside. But this time, instead of the application load balancer, we are going to use an API gateway. And particularly, this API gateway is a HTTP API. Now, as you may know, API Gateway supports two types of API, the REST API with all the standard supports, and also these HTTP APIs. And out of them, the HTTP APIs has lower latency and it is cheap. So we use that. And you can also notice another difference, that is the API gateway connects with our ECS cluster through a VPC link. Now, why do we have to use this VPC link? Unlike in the previous case where the load balancer was inside our VPC, API gateway is outside the VPC, and this is a fully managed service. So in order to access resources inside a VPC, we need to use this VPC link. And next, for service discovery, we will be using a new service called CloudMap. Now, this is a big difference. Now, in the first approach, the application load balancer itself, it did the service discovery. Now, although the load balancer can identify the IP addresses and keep track of it, the API gateway cannot do that by itself. So it has to use another service, and this service is called CloudMap. Now, this CloudMap service is particularly designed for service discovery. It can keep track of containers that is inside a microservice architecture in a highly scalable manner. For example, you can connect your ECS cluster with the CloudMap, so it will keep track of all the IP addresses and the ports of each of these containers. Then we can integrate this CloudMap with HTTP API. So the API gateway can also access these IP addresses because it is already listed in the CloudMap. And afterwards, API gateway can route traffic to those private IP addresses through this VPC link. Now, the main advantage of using this approach number two is that we can use all the API features in HTTP API, which we couldn't otherwise when we use the application load balancer in the previous approach. Now we can also easily integrate with services like Cognito and handle our user authorizations as well. And not only that, the API gateway can also handle the API throttling and also multiple stages. So now in this approach, users are going to access the API gateway instead of the application load balancer in the first approach. So I hope both these approaches are now clear to you, but I think it is not complete until we get some hands-on experience with this. Yeah. So next, let's use the Amplify CLI to create a similar architecture like in approach 2 using few lines of codes and a Docker file. Okay guys, so let's start by creating a new directory. I'll call this serverless container, and I'll cd into a serverless container and first open it in Visual Studio Code. You can use any code editor of your preference. And here I'll take the integrated terminal. So here in this demo, we are going to create an Express API and containerize it, and then we will serve it through the container. So before we create our Express API, let's initialize an Amplify project. I will do it, Amplify init, and hit enter. And by the way, you need the latest version of Amplify. So currently what I have is 4.41.0. And there's a new update as well. You can use this to install it. And after that, you need to configure it. I'll put the links in the description how to do that as well. So the project name, I'll just accept as it is. And dev environment is fine. Using VS Code, JavaScript. And we don't use a framework at the moment because this is the API. So I just click none. Now we need to create a directory to have our source. So for that, let's go ahead and create it src, and the default one is src. That's why I created a folder called src. Hit enter. For distribution file or the build file, we run another folder and we'll call it dist, and there is the default one here as well, as you can see. Hit enter. So the build command, for that to happen, we need a package.json file. So let me take another terminal while the other one is running, and I'll do an npm init here -y. So I'll get a package.json file. Here we go. And I'll go back to the previous shell, this one. And here we go, we are here. So the build command is this, and start command, that's fine. Okay, so now it's creating our Amplify environment. And I'm going to be using a AWS profile. You can create a profile when you are configuring your Amplify. So the project is successfully created. Now we can go ahead and add resources. So as you can remember, we are using the second scenario where you will need an API gateway to call your containers. So you'll be tempted to do this, Amplify add API. And of course, we are going to do that. But before that, there's a one additional step we need to do. So that is nothing but Amplify configure project. So why we do that? Now this is basically to tell this Amplify project is a container-based Amplify project. Usually, when we create an API with Amplify add API, so it's going to create either API gateway or AppSync API, and the backend resources probably be Lambda functions and other serverless functions. But here our backend resources needs to be containers. So that's why we need to separately say this is a container-based project. So I will just accept the same name for the project, VS Code, JavaScript, and none. Okay, you have to accept the same thing. Now, you might be wondering why we couldn't do this when we are initializing the project, and unfortunately, that option is not available just yet. So, this is the option I'm talking about. Now, this prompt is not given to us when we are initializing the project, but it's only giving to us when we are configuring the project again. So, it says, do you want to enable container-based deployment? So, this time I'm going to say, yes, I need that. So, it will update our project. Okay, the new configurations are successfully made. Now what we can do is we can simply add the API, Amplify add API. So I can select whether I need a GraphQL or a REST API. I'll choose REST. And now we have different option. Earlier, the default option is API Gateway and Lambda, but now we have API Gateway plus AWS Fargate. This is container based. This is what we need. So I'll hit enter and I'll accept the default. Now I can use already pre-built templates. You know, there's Express.js template with the REST template and Flask template, or else you can create your own Docker file and Docker Compose file. So you can go ahead and check this template, but this time I'm going to use a custom mood. That means I'm going to create my own Docker file and own Docker Compose file, and I'll hit enter. Then it will ask me when do I want to deploy the containers. So I'm gonna go ahead and say on every Amplify push, I need to run the deployment pipeline. So I'll select that and hit enter. And I'm not going to restrict the API. And if you need to add Cognito and add some authorizations to your API, then you can go ahead and say yes. But in this case, I say no. So this is a public API. So now I can do Amplify push. So it's going to go ahead and create that whole setup for me. By setup, I meant this whole architecture. You see, it's going to create the VPC, subnets, and although it's not a private subnet, I think they're creating public subnet. We'll verify that. And you know, it's going to create the ECS cluster for us. It's going to create an API gateway and set up the VPC link and also the CloudMap for service discovery. It's not going to create, I believe, a Cognito because we have not made this as a restricted API, but the rest will be configured. So I'll go back here and I will continue it. Oh, it says there's no definition available. Our bad because we couldn't create the Docker file or a Docker Compose file. So let's go ahead and do that. For that, I will go to Amplify folder here. Let me expand it a little bit. Then I'll go to backend and then I'll go inside the API folder. So right now I am in the source folder. And inside this source folder, I will create the Docker file and also the Docker Compose file, YML. Yeah. All right. So next we need to add our Express API code. And I'll be using TypeScript here. For that, I will create two folders. The first one, let me call it app. And this is where my TypeScript code lies. And I'm going to create another folder. Let's call it lib. And this is where my compile JavaScript code going to stay. Okay, now we need a tsconfig file. For that, I'm going to open this folder, this source folder, and I'll open it in integrated terminal. Okay, and if I ls it, then I see my Docker file, app and lib folder, and Docker compose file. And here I need another package.json file. So I'll do npm init-y, and it will create a package.json so I can install TypeScript. npm I -- save dev TypeScript and hit enter. So that will install it as a dev dependency. If I just look at my package.json file now, and here we go. So it is installed as a dev dependency. Clear my screen, and then I'll use npx command, npx tsc -- init to initialize a new TypeScript project. And here we go. Now we have a tsconfig file inside this source folder. Okay, so now let's set the target to, let's do it ES 2018. Common JS is right. Source map will enable it. And these two we need to configure: out directory and root directory. So our root or the TypeScript code will be inside app folder, and the compiled JavaScript will be in the lib folder. Okay. And I'll also make sure the module resolution is node and the rest is fine. Okay, I'll save this. Okay, I'll close all these files, and then I'll go to app folder. So this is where we write our TypeScript code, and I'll just add app.ts file. Now we'll be using Express.js to create our API, so that let's install Express, npm I express, and then I will clear the screen. I'm going to install the types for Express and Node.js as well. Types/express and also types/node.js. This could be dev dependencies. Okay, great. So if I go to package.json, I see these dependencies. So let's first, so now let's start creating our API. First and foremost, I will import Express from Express, and then I'll create Express app with Express. So let's create the root route now. I will do app.get, and if any request is made to this root route, I will just send the response as hello world. So I need to get the request and response variable, and I will, or parameters rather, rest.send hello world. And then let's listen to port 80. Console.log. Okay, this one got imported for some reason. Let me take that out. Cool. And we are going to enable cross for all the methods as well. So we can call this API from any domain. So let me paste this bunch of code. And here I'm using this as a middleware to allow all the cross-origin requests. And instead of hello world, I will rather say it hello from container, because this is running inside a container. So this looks good. Let me quickly test it locally. I will first compile this code to JavaScript. So tsc, hit enter. Then I should see my JavaScript code inside my lib folder. Here we go. And I'll go to my package.json file. Let's add a script. I'll call it serve. And I want to execute this app.js file inside the lib folder. So let's do node. Inside lib folder, you will find app.js file. Okay, node lib/app.js. So let's see if it works. So I'm at the source directory, as you can see. Then I'll do npm run serve. Okay, so it says listen to port 80. So let me take a browser and do localhost and hit enter. Here we go. Hello from container. So our application works. Now we need to Dockerize it. So in order to Dockerize, earlier we had Docker file and the Docker compose file. So let's go to the Docker file and I will paste some instructions here. Save it. Now you can find the code in the description section. So essentially what it's going to do is it's going to use a Node.js image, Node 14.15, and we are using public ECR repository instead of Docker Hub. You can use Docker Hub as well, but since they released this public ECR recently, I'm using public ECR here. Then I'm setting the work directory as /app, and I'm going to first copy over the package.json file into this app folder inside the container, so we can make use of Docker caching, and then I will do npm install to install Express really, and then I need to copy the code. So I don't want to copy the TypeScript code, I just need the compiled JavaScript code. So that's why I go inside the lib folder and then copy it over to this app folder inside the container. Then this is important, you need to expose 80, and this is a requirement for Amplify container deployment. So expose the port 80 or any port that you will run your container. And finally, we are going to run npm start. So we have not added that command yet in our package.json file. So let's go ahead and add that as well. Start. And here I can just say node app.js because we copied over the content inside the lib folder into our container. So the context is inside the lib folder now. So I can just say node app.js. Okay, so this is going to create a Docker image for us, and then we can spin up Docker containers out of it. And for that, we'll be using a Docker compose file because it is easy to compose containers with Docker compose file rather than using the Docker CLI. So let me copy over some code here, paste. So here in the first line, I specify the version. So this is Docker compose 3. However, Amplify recommends to use 3.8. You can use that too. And then I'm defining my services section. So my first service is the app. Here I need to specify where my Docker file is. So right now I'm editing the Docker compose file. The Docker file can be found right next to it in the same level. Then I will expose port 80 to outside, and that maps the port 80 in the container. So let's check this if it works locally. And to do that, you need to make sure you have Docker installed and running. Now to run our containers, I will use Docker Compose CLI. I will do Docker Compose up, and before that I need to build it. So I'll pass it as a flag --build, and let's hit enter. So it will walk through the instructions in the Docker file, and it will pull the Node.js from public ECR repository and create the work directory app, copy over the package.json, install the dependencies and all that. You can see the steps right here. So now it is running the npm install. It will copy the code, and finally it will run the command npm start. Now I should be able to access the same local host, and this time it's going to serve from inside the container. Here we go. So it works. So if I stop it, you can just verify that. So I just stopped the Docker Compose, or the container really, and if I now do that, I don't get anything. Okay, seems like our Docker Compose file and Docker file is ready to deploy. So let me clear the screen now, and now let's do again Amplify push. So it's going to deploy my API, and I will just say yes and hit enter. And this is going to take some time, guys, because it's going to configure and provision many resources behind the scene. And this architecture, to be exact, although it should be public subnet instead of private subnet. Let's verify that, by the way. Okay, guys, so the deployment is completed, and we have got a REST API endpoint, so we can access our API gateway. And let's check that out. I will copy this and let's access it from the browser itself. And here we go. I got the message from my container. Hello from container. Now guys, we only did Amplify push, but Amplify behind the scene has done quite a bit of things. Now that's why I took some time to explain it ahead of the time. And if I show you the diagram I have right now, so it went ahead and created the VPC, subnets, and ECS cluster, ECS service, and also the API gateway, and it did the integration through a VPC link, and it also created the cloud map for service discovery. And although we didn't use Cognito here, it has done quite a bit of provisioning and configuration. I hope this is clear for you now. Now finally, before winding up this video, let me show you those resources that Amplify has configured. Now first I'll show you the network stack, that means the VPC and two subnets. So let me go to AWS console and go to VPC section. Now you can see this VPC, it's called Amplify/VPC do not delete. So let me just copy the VPC ID and let's go to subnet section. So there are multiple subnets. I will filter by that particular VPC. Okay, I'll click here, Amplify VPC. Then I should see the subnets. Now there are three subnets, and in the diagram I've showed only two subnets. So here there are three subnets. If I click onto one of that, and I'll go to the route table, and the route table associated to this subnet has an internet gateway attached to that. So that means this is a public subnet. So let's check the other two as well. So the second subnet, and this also has an internet gateway attached. So this is again a public subnet. Let me check the last one. And here in the route table section, so this one also has an internet gateway attached. So all three subnets are public subnets. So that is something to remember. Maybe in future they will add some options to choose whether those are private subnets or public subnets. But for now it's public subnet. So we looked at the VPC and two subnets, or rather three subnets. Then let's look at the ECS cluster that is inside this VPC. So I'll go to services and I'll search for ECS, Elastic Container Service, and open it in a new tab. Now this is our ECS cluster that Amplify configured. You can see it is Amplify dash, the name that we have given, serverless container dev, and some other information. And you can see this is a Fargate type. So it is a serverless compute. And if I go into this cluster, and let's see where the containers are spinned up. So here's our service. You can see we have this service. So that is this service here. So I'll click onto that. And in this service, Amplify has set the desired count to 1. So that means at any point of time, there should be at least one container running. Now here in the diagram, I have added 6, but instead now we have only one container. And out of that, one is already running. So let's check this. And if you go to the network access section in the service, you can see the VPC that is associated with this. Let's say that should be the Amplify VPC. I will open it a new tab. And here we go. So this is the Amplify VPC. So that's all good. And next, let me show you the API gateway. So I'll go to services again and search for API gateway. And here we go. Open it in a new tab. And this is that API, Amplify dash serverless container. Now this API gateway is accessing our containers that is inside the VPC through the VPC link. So let me show you that. If I go to here, VPC link section, and I should see the VPC link that Amplify has created. So the API gateway can connect to our VPC through this VPC link. Next, how does API gateway know the IP address of this container? And that is thanks to the CloudMap integration. Now the CloudMap is a service discovery service, as I already explained earlier. And if I go to the integration section here, I can see the default route is pointing to the service discovery. So if I click onto this one, and you can see AWS CloudMap service is here. Now here in the CloudMap service, it is creating a namespace. Now let me show you that namespace. If I click edit here, yeah, these are the namespaces. If I click this drop down, here's the namespace that Amplify has created. So in our ECS cluster, we will use this same namespace, and from our API gateway, then we will use this namespace as well. So what is this namespace really? So this namespace is being created by ECS cluster, the cluster that Amplify has created for us. So when it is creating the cluster, it has created the namespace in CloudMap and associated this cluster with that namespace. So from our API gateway also, we will be accessing the same namespace. Thereby, CloudMap will return the IP addresses and the port of the containers. So that's how it all happens. So the API gateway call to the CloudMap, and in from the namespace it get the IP address and the port, and then through this VPC link it will connect to that container IP, and then it will get the response and send it to the users, and it will show the message from our container here when we access the API gateway URL. Now there's one other thing I want to share with you guys. When we are using this architecture, there's certain cost is involved. Now, one reason why we use containers instead of Lambda function is to prevent cold start. And these containers will keep running all the time. So whether or not you use them, you have to pay for that uptime. So unlike Lambda, where you will be only charged for the Lambda execution time when the Lambda function is invoked, here you will be charged until this container is down. So I hope it is clear. You go here and maybe you might want to delete everything. So do amplify delete and amplify delete the entire stack, including all the resources. Yes, and that's it. So make sure you do this if you are just testing this out. Otherwise, you'll be charged. I hope this has been useful, and I'll see you in another video.